So I'm going to talk about a digital solution that we use, we create in Spain, and now we are using in a lot of countries. First, I will introduce the company which I belong. These are the topics that I'm going to go along. Is introduction, industrial discharge control, the digital solution that we create, and our use cases. Okay, so my company comes from a water utility with more than 130 years of experience. 25 years ago, they decided to create their own software, and they have been very successful. So they decided to create a spin-off of this company and create software for other water utilities. And 2 years ago, we have a partnership with Silent, and we create the portfolio of digital solution that is called Silent View. We have projects all across the world, and this is the architecture of our digital platform. The first layer is about data acquisition from IoT, from other third-party digital platforms. Then we gather all this data and we standardize this data, and then we use this data in digital solution for all the wastewater and the water cycle, and all of them are wrapped in our portal called the Silent View portal. Okay, so this is the portal that I have said. Here you can access to all of our digital solution that we have for drinking water, for wastewater, for irrigation, billing, and a lot of things. And in this session, I'm going to speak about the digital tools that we use to control industrial discharges in the sewer network. Before showing you the digital tool, I want to talk about how to control the industrial discharges, or at least how we control in Europe. So the industrial discharge control try to solve some questions at who is polluting, the patterns of the pollution, what pollutant are they discharging to the sewer network, and how to create a plan to control this. And the objectives are to meet the authority discharge limits, reduce the discharge, and protect the wastewater treatment plant and the wastewater network. Okay, so these are some examples of the samplings that we have taken from industrial discharges. A food company, winery, textile, oil and grease, citrus. Okay, and these are some examples of the problems that this industrial discharge can cause. In the wastewater treatment plant, they affect the process, so it's very difficult to have a compliance with the limits in the contaminants in the effluent. There are also damage in socioeconomic, for example, when a beach is closed because of the contamination. Also infrastructure damage, and it affects also to human health and ecosystems. Okay, so this is an example of what we can achieve if we start control our industrial discharges. This is in a region of Spain. They start control the industrial discharges just doing a lot of samples to these industries, and in Spain the sludge that wastewater treatment plant produce, if it has no heavy metals, they can send this sludge to the agriculture, so it's very cheap and more sustainable. But if they have heavy metals, they have to go to landfill or to incineration. So from the year we start doing this control to the industrial companies, we reduce the amount of heavy metals in this sludge, and we save 7 million per year in sending this sludge, this contaminated sludge, to incineration or to landfill. So how do we control the industries in the traditional way? Okay, the traditional way, you start analyzing your municipality, where are these industries, which industrial activities they have, what pollutant do they discharge to the sewer network, and then you create a plan to sample these industries. And I mean by sample is someone has to go where these industries discharge the water and take and grab a sample. Okay, and what happens when you grab the sample and it is a non-compliance with the law? So it's very hard to know if you don't take the sample just in the exit of the industry. It's very hard to justify that this industry is the responsible of the discharge. And also, if you have this kind of sample that is punctual sampling, sometimes industries know when you are going to take the sample and they change the process in order to comply, and other times these industries are not working at these times. So just for an statistical point of view, if you just have an example of an industrial plant that has 5 events of discharge every, and these 5 events are 30 minutes. If you take a plant of discharge control of 12 samples per year, the possibility that you take one of these discharge is 1 in almost 300. So it will be very difficult to control the industries this way. Okay, so what are the challenges of the traditional methods? The challenges are that we highly depend on the knowledge, the previous knowledge of the area. There is also very difficult. It's also very difficult to have all the data integrated in one point to have insights that clarify who is discharging illegal discharges to our network. The intermittent control grabbing the sample is not very efficient, and also our wastewater treatment plant are exposed to these discharges without a previous alarm. Okay, and these are the challenges that we are trying to solve using our digital platform. This is the digital platform. We call it Sewer Tracker. And Sewer Tracker use as data sources the results of the sampling that they are taking in the sewer network and also in the wastewater treatment plant. It also integrates the variables from the SCADA and also other external sources of data as meteorological data and work orders data. And the most important part is that we use instrumentation installed in the sewer network to control in real time the quality of our sewer network. That way we can know if the industry is discharging or not, and we don't have to send someone to take the sample. Maybe it's not the moment where they are discharging and we have a run inside. So with all of this data, we create different functionalities. We have all the industrial census in our platform. We have the GIS. This platform is connected to the work order system, so we can send an order to change the instrumentation or to clean it or to take a sample. We also have a matrix that matches the principal industrial activities with the principal pollutants that they use to discharge, and we have 3 advanced functionalities that I'm going to talk more in detail later. Okay, so this is our platform. Here is the dashboard, and for example, we select the time period that we want to analyze. Once we select the time period, we can see how many alarms we have in this time period, how many samples are taken, and how many sensors are installed, and the pollutant index. we can see some data of the alarms, and if we jump to the other section, that it is the industrial detail, we can see where are all of our industries in the municipality. The colors are the different industrial activities, and here, for example, I'm going to sort by textile industries. So you can see that all of these three industries in this municipality are textile, and if I go to one of them and see the details of the industry, you will see that we have the industry located with the main data to contact them. We also have the industrial activity with the main pollutant that we should control from this industry, all the documentation about this industry, and also images that we can upload to the images. Okay, the next section that I'm going to show you is about the sampling points where we control the network. These sampling points can be sampling points where someone take a manual sample, or it can be sampling points where is a sensor installed. Okay, so this is one of the sampling points in detail. I don't know what is happening. Okay, so here you can see the network that is upstream this sampling point, and all of the industries that are discharging to the sampling point are shown there. Okay, and you can see also the data that we have from the sampling points. This is the sensor data. Here we have installed a pH and a conductivity sensor, and you can see here the values in real time. Also, we can see if in this sampling point we have any alarms. We have an alarm of electrical conductivity. And the next thing that I'm going to show you is images. So here we have the sensor installed in this manhole. Okay, I'm going to jump. Maybe it's the slide. It's possible to solve it? Okay. Okay, so this is one of the advanced functionality that we have, that is machine learning for algorithm for detect the industrial discharges. This algorithm is anomaly detection algorithm. It do an anomaly detection phase, then a pattern research, and then it categorize all these patterns, so we know in real time if the data that is coming is industrial discharge, is a failure of the instrumentation, or it's okay. Can you jump to the next one, please? Okay. The other functionality that we have is that we can estimate the volume of the discharge when we have an alarm, and we also can estimate the transit time between the point that we have detected the discharge until it reaches the wastewater treatment plant. So in this way, if the wastewater treatment plant has a storm tank, they can store the industrial discharge there and process this slowly in order to not kill all the microorganisms in the bioreactors. The next advanced functionality is, okay, the client want to have this and they don't know where to put their control point in the sewer network. So we create this algorithm in order to help them to know where to put the control point. This algorithm uses a lot of criteria. For example, the number of alerts that you have, the criticality of the industries that you have, and with all of these criteria, we create an optimization cost function, and this function we solve it using an algorithm, a genetic algorithm that runs a lot of iteration, moving the sampling points to one place and another, reducing this cost function, until we have the best solution for our sampling points. And this is a real use case in a municipality where we have a lot of problems with industrial discharges because they have a lot of industrial activity. The wastewater treatment plant is always having problem with their biological reactor. It has a lot of non-compliances, and it also has a lot of environmental impact and complies from the neighbors that suffer from this. So we install 11 sensors in the sewer network, and we start detecting a lot of industrial discharges. And one of them was a recurrent discharge from one industry. Like every week, even more frequent, we have an industrial discharge. We detect this discharge in the whole path of the sewer network, and when it reaches the wastewater treatment plant, it generates problem with the sludge. So it increased the cost of operating the wastewater treatment plant, and also the wastewater treatment plant can't comply with their limits. So with Sewer Tracker, they were able to know where this industrial discharge come from, and they were able to know in real time when this industrial discharge take place, when it's going to reach the wastewater treatment plant, and the volume of this industrial discharge. And also, they know the industries that are upstream. So with this insight, they were able to know the industry that is generating this industrial discharge, and they put a fine to this industry, and the industry stop discharging this. So thanks to this, we help to the wastewater treatment plant to comply with their limits. We also help to reduce the cost of the aeration in the wastewater treatment plant, and help to reduce the cost of sludge management in the wastewater treatment plant. And I would also want to say that we are not just offering the software to control the industrial discharge. We also offer the consultancy in order to help you to select the sensor, and to help you to select the points where they have to be installed, because this is a very innovative approach to control the industrial discharge, and we can have a lot of problem with the sensor if we don't do a good job here. And that's all. Thank you.